Hi everybody, welcome back. What we're going to do right now is talk about section 1.3 from the textbook. So that's chapter 1, section 3. And what we're going to focus on is this part right here about different types of research studies. And all research studies involve collecting data on different variables. So the way we're going to begin is by talking about what variables are. So all research studies measure variables. And a variable, as the name implies, is just simply anything we measure that can take on different values. So the values of the measurement can vary. So for example, this is very straightforward. Think about a person's sex. If we're measuring people and we're also measuring their sex, a person could be a male or a female. So that level of information that we're collecting can take on different values. Think about, for example, a person's age. Ages, of course, can vary, so age would be a variable. Think about something like political party. People are Democrats or Republicans or independents or something else. So clearly a person's political identity can vary. So that's a variable. All right, well, let's just kind of quiz ourselves real quickly. Identify the variables of interest for this study. Imagine this study here. A researcher discovered that, on average, college students who smoke pot tend to have lower grades than students who do not smoke pot. All right, well, keep in mind that in any research study, we might be measuring a variety of different variables. And in this particular case, there are two. Students often get a little bit confused, and they'll look at an example like this and they'll say, well, one variable would be the college students. Well, the college students are the subjects of the research study. So they're not necessarily a variable of interest that we're actually measuring. They're the participants involved. We typically call them participants or subjects. So of the people who are involved, what are we measuring them on? That's what we want to focus on. Well, we're measuring to see how much pot they smoke, and we're also measuring them to see what their grades are in this particular study. We're finding that the people who smoke pot tend to have lower grades. So there are two variables. One is the amount of pot that the students smoke, and the other is their grades. Okay, so it's that straightforward. Once we go through a couple examples, you'll have it down pat. And of course, my intention with these videos is to go through things relatively quickly, help you get a basic understanding of what's going on. Hopefully you'll study this stuff, you'll practice a little bit, and then in class I'll quiz you a little bit more and I'll take any questions you have. So let's move on and start talking about the different types of research studies now that we have a sense of what variables are. Because we're going to measure those variables in a variety of different ways. We're going to talk about two basic types of research studies. The first type that we're going to discuss is an observational, also known as a correlational research study. And in my field of psychology, we always refer to these studies as correlational. However, I found that in medical research, they almost always refer to these studies as observational. The reason why I really don't like the term observational in this case is because all research is really based on observation. We're always looking at things and measuring things. So all studies involve some form of observation. So I just find that term in this case a little bit confusing. But it's fine to refer to these studies either way, observational or correlational. We just want to make sure we understand what they're all about. And in an observational or correlational study, researchers observe and measure characteristics of our subjects, but we don't attempt to influence them or modify anything. And we don't test any treatments or manipulations. The bottom line is we are really just kind of sitting back and measuring things. And then the goal ultimately is to figure out how those things relate. So that's where the term correlational really works out well too, because I'm going to measure variables. I'm going to sit back there, measure some variables, and then see how they correlate. All right, so this is a correlational study. Now, let me give you an example, and you'll see here, this is the same example that we used before. In this type of study, I'm not testing any type of treatments. I'm not trying to help people. I'm not manipulating anything. You're going to see a key thing in an experiment. Another type of study that we're going to learn about is that I'm actually manipulating something. So that's going to be one of the key ways that we can determine if we're dealing with an experimental study or a correlational study. And in this case, we have a correlational study, and we can see that I'm not manipulating anything as the experimenter. All I did was I measured students essentially asked them, found out how much pot they smoke, and then I looked at their grades to see how high or how low they are. So I'm not really very involved in this type of study, in an observational or correlational study. So we did in this study find a correlation. We found that students who smoked more pot tended to have lower grades. And we refer to that as a negative correlation. And that's because the two variables are kind of working antagonistically, if you think about it that way. As one variable goes up in value, the other tends to go down in value. So students who smoke a lot of pot tend to have lower grades. You see how those two variables are working antagonistically? Students who are smoking more pot have lower grades. And the flip side of that, of course, is also true, showing a negative correlation. Students who do not smoke a lot of pot tend to have higher grades. So that's a good example there of a negative correlation. Here's an important point that I've highlighted right over here. A correlation between variables does not prove that one variable causes changes in another. So from this type of study, because it's correlational, because I didn't actually manipulate anything, I don't have any control in this study, I can't actually prove that it's the pot smoking that is directly influencing the grades. And my question to you is, why not? We'll go through some examples like this in class. Let me kind of give you some potential answers to this one, just to get you thinking about it. Now, as I mentioned, I'm not really highly involved in this type of study as the researcher. I'm just measuring variables. So that means I don't have a lot of control. When we start talking about experiments, you're going to see that I'm going to have a lot of control over what happens in the study. But in this one, I'm just measuring. How much pot do you smoke? What are your grades? Well, as such, because I don't have that control, a variety of things could be going on. So for example, isn't it possible that the students who smoke pot are also just less serious about school? And because they're less serious about school and they're dedicating less time to school, that's why they have lower grades? So the lower grades really have nothing to do with the pot. It's just that those students are fundamentally different. They're less serious about their academic work. The point that I'm trying to make here is that with this study, we can't rule out that explanation. So because I can't rule out that explanation, there's essentially a confusion. I don't know what's causing what here. It could be the pot that's causing the low grades. It could be that the students are less serious about school and that's causing low grades. Because there are all these potential explanations, and trust me, we could play this game all day. We can find all kinds of potential explanations for this correlation. Because there are all these potential correlations, correlational studies ultimately cannot prove causation. So it's very, very important that you can identify when we're dealing with a correlational study, because then you can understand the limits of the interpretations of the results. Because we will know that this type of study is not designed in a way in which we can prove causation. This study did not prove that smoking pot causes lower grades. It just showed that there was some association. All right, well, let's talk about these observational correlational studies, because we can break them down into two common variations. Typically with these studies, data is collected pretty much like all at once or very close in time, kind of like in the situation we just talked about. I would probably give people a survey, these students, and I'd ask them about their drug habits, and I'd ask them about their grades. So I'd be collecting that data pretty much all at once or very close in time. There are some variations though. Let's talk about a retrospective study. In a retrospective study, we're using data from the past, and that whole retro word, or the root of the word, kind of gives you the tip there, such as like some official records, hospital records, something like that, or school records, past interviews. We're just kind of using some information from prior times. Here would be a good example. In a study of hundreds of Swedish twins, researchers found that mental ability was more similar in identical twins than in fraternal twins. This is a common finding, that identical twins, who are essentially genetic clones, tend to have more common characteristics than fraternal twins, who are brothers and sisters just like any other brothers and sisters. They were just born at the same time. So the key thing here, how we can tell it's a retrospective study, is because these researchers were looking back. They were looking back through medical records to identify twins who were either identical or fraternal. And then they were correlating that information with some information about their cognitive ability, their mental ability. Let's go through another example. I said there were two common variations of these observational studies. And this other one is a prospective or longitudinal study. And really that alternative term, longitudinal, helps you understand that we're kind of looking long range, often into the future, prospective study. So that's designed to collect data in the future from groups that share some common factors. Here would be a good example of that. In a study that tracks the health of over 100,000 nurses, and there are lots of research studies done on people in the medical profession, researchers found that those taking hormone replacement therapy have a higher risk of heart disease. This is actually a very famous study over the past decade and a half or so. I'll use this as an example several times throughout the semester. And it's prospective because what was done in this particular study was women were looked at over time, over a long period of time. In fact, the researchers are still looking at these women. And they're just taking some measurements about their hormone replacement therapy status. Like, are they taking hormone replacement therapy drugs or not? And they're looking at their heart and how healthy they are. So that later on they can put those variables together to see if there's some type of correlation. Are the women taking hormone replacement therapy more likely to have some heart problems? So do you see how now we're looking into the future with this type of study? It's still correlational, and it's correlational because, again, I'm just kind of sitting back. I don't have a lot of control over what's going on. I'm just simply collecting the data. I'm measuring the different variables and seeing how they relate. I'm not deciding who gets the hormone replacement therapy and who doesn't. That's what would happen in an experiment where I have lots of control. I have no control. I'm simply asking these women, are you involved in some hormone replacement therapy regimen or not? And then I'm looking at their medical records regarding their heart. So do you see in an observational study or a correlational study, I have very little control over what's going on. All right. Well, we're going to contrast a correlational study with an experiment. So let's talk about that second basic type of research study now. And you're going to see that experiments are very different than correlational studies. You're going to see that I have lots more control over what's going on. Because in an experiment, like we say right here, researchers apply some treatment, and then they observe the effects of that treatment on the subjects. So I'm going to decide who gets this treatment. I'm going to decide who does not. And then I'm going to very carefully measure these people on some variables to see how they might differ. So I'm going to develop two different groups. I'll have a treatment group, and that treatment group, also known as an experimental group sometimes, is the group of people, we often refer to them as subjects or participants, who will receive the treatment being tested. And the control group in an experiment is the group of subjects who will not receive the treatment being tested. And they'll often receive a placebo or maybe some standard treatment if we're trying a new treatment. So just to give you a real quick example, think about that hormone replacement therapy study. If I wanted to make that a true experimental study, I would decide who gets the hormone replacement therapy and who doesn't. So I would create two groups. Some of them would get hormone replacement therapy, and some of the women would get a placebo. Or possibly I would be testing some new hormone replacement therapy, and the people in my treatment group would be getting this new drug for hormone replacement therapy, and the people in the control group would get some standard treatment. Right? But I'm deciding who's in each group. So a good follow-up question would be then, how should we determine who goes into each group? Well, this is really the key of an experiment. Because I have all this control, I can equalize these groups. Do you remember the problem we had with the pot smokers? And it was possible that the pot smokers were fundamentally different from the students who didn't smoke the pot. And their low grades might be because they were fundamentally different. They just weren't as serious about school. I need to make sure that doesn't happen in an experiment. I need to make sure that those groups start off essentially equal. The way I do it is through random selection, random assignment. Those are two different terms for the same thing. Sometimes people call it random selection. How do you randomly select people to put them into the groups? Some people, like me, call it random assignment. How do you randomly assign people to the different groups? So two different terms meaning the exact same thing. Do not confuse random assignment with random sampling. Random sampling, you might recall, was used to determine who's going to be involved in our study. How are we going to randomly select people to be involved in our study? But now once they're in our study, I need to determine which treatment group they're going to be in. The experimental treatment group or the control group. That's when I use random assignment. And it's as the name would imply. I will randomly place people into these two groups. If I have two groups, people who are going to receive hormone replacement therapy and people who are going to receive a placebo, I might flip a coin to determine who will be in each group. And the reason why I want to use some random process is because in the end, the two groups will start out approximately equally. So, ultimately I'm trying to look at how hormone replacement therapy affects heart disease. Well, if I use random assignment, I should have approximately equal proportions of women in each group who have parents who have heart disease already. I should have equal numbers of women in each group who drink moderate alcohol. I should have equal proportions of women in each group who have college degrees. All of these little things that could affect the study will be canceled out because I'm using a random procedure to create those groups. So that's why I often refer to random assignment as the great equalizer. If I randomly assign people to the groups, I will start off with equal groups. And that's a beautiful thing. Let's discuss experiments in a little bit more detail so you can better appreciate it. So let's first just make sure we understand the key terminology. So let's identify the treatment and control groups in this particular study. This is a really pretty neat study. It was not done in America. This type of study is typically not the type of study that would get approval in our country. After trying defibrillation unsuccessfully, European ambulance crews randomly assigned half of the 1,186 patients to receive a new drug, which was called vasopressin, and the other half to receive a standard drug, epinephrine. Those receiving the new drug improved their chances of reaching the hospital alive by 40%. So we're talking about people in some very dire circumstances. They were not responding to basic resuscitation techniques. At that point, they essentially flipped a coin. Half the people received this new drug, half the people received the standard drug. So it's a good experiment. We can see that people were randomly assigned to those two groups. And we found that those receiving the new drug, the vasopressin, improved their chances of reaching the hospital alive by 40%. So identify the treatment and control groups. All right, well, the people who are receiving the new drug are typically the people who we would say are in the treatment group because we're really testing to see if this new drug works over this standard drug. So the control group isn't receiving a placebo. In this case, they're receiving the standard drug, what we typically would administer in this situation. So the treatment group in this case received the new drug and the control group received the standard drug. There's some other terms that I want to talk to you about in this situation. The type of drug in this case has two different levels. They're either receiving the new drug or the standard drug. That's the explanatory variable, the type of drug. And the response variable is the survival rate. So we're trying to determine if the type of drug they received had an effect on if they reached the hospital alive, the survival rates. So we would call the drug the explanatory variable, often also known as an independent variable. And then the survival rate, the other thing we're measuring, is the response variable or the dependent variable. These are just different terms that tend to be associated with experiments. So there are some ways that you can try to remember this. The researcher is independently manipulating who's going to receive each type of drug. And we want to see if that drug has an effect on the survival rate. In other words, we want to see if the survival rate depends on what type of drug they receive. So I'm not telling you here that the terminology is always really easy to just kind of remember and master, but these are the terms that are used when we're dealing with experiments. So it's important that we're familiar with them. Let's go through another example. Same actual example, but what I want to focus on here is identifying some ways that we establish control in this experiment, because the main point that I was trying to make between experimental studies and correlational studies is in experiments we have this amazing amount of control, and that's a good thing. Because in the end, if I find out that this drug, this new drug vasopressin, improves chances of reaching the hospital alive by 40%, if I find that, I want to be able to say it's due to the vasopressin. Now remember, before I couldn't say that the low grades were due to the pot use because there are all these alternative explanations. That's not the case in this situation. Well, you might say to me, like, well, you know, I think maybe the people in the vasopressin group, the people in the treatment group here, maybe they were just a little bit more healthy to begin with. And I'll say, I don't think that's likely. And it's not likely because I randomly assigned people to these two groups. And if I randomly assigned people to those two groups, they should have started off about approximately equally healthy. So do you see, I have so much control here by determining who is put into each group, and I'm able to standardize those groups, that it allows me to establish causation. So let's just identify a couple ways in which we're really able to establish that control. One, as I just mentioned, the experimenter randomly assigned the subjects to the groups. So the experimenter decided who received the treatment. That's an amazing thing. Previously in that other study, I did not determine who was smoking pot. And obviously that's why we can't do an experiment in that situation. It wouldn't be legal for me to randomly assign some people to smoke pot and then other students not to smoke pot, and then at the end of the semester see if it affects your grades. I can't do that type of study. That's why, even though correlational studies can't prove causation, they're still done. They're very, very helpful. It's just they're somewhat limited in their causal explanatory power. In this case, I was able to randomly assign people to groups. Here's another way that we establish control in an experiment. The experimenter recruited a large number of subjects. Sometimes you'll hear about studies being conducted that have not a large number like we see here, but like there were 10 people studied, you know, and those 10 people were split up between two groups. Well, you know, when we just have like 5 people in each group, we're really not giving the study enough time to kind of work itself out. Any one person here or there having a success or a failure in our study can have a really profound effect. Now, one person out of 1,186 is kind of small potatoes. So over the long run, we can really see the trend of what's happening. But with just like 10 people, we really can't see long-term trends. So that's another way that we established control in this study, by recruiting a large number of subjects. Here's another really important thing. In this particular experiment, it was double-blind. And when I say it was double-blind, we're talking about a method in which the researchers are trying to protect themselves from kind of making some mistakes and introducing bias. And when we say it's double-blind, there are kind of 2 ways that we're using blinding. One way is that the actual patients in this situation, well, they're unconscious. They didn't know if they were receiving the vasopressin or the epinephrine. And, you know, usually in a study, people are not unconscious. So if they are conscious and they know what drug they're receiving, if they know that they're receiving some standard drug or a placebo, then they might not have those high hopes. In fact, they might be somewhat let down, like, oh, I'm not getting the new drug. And those hopes might affect the actual outcome. Because of course our brain and the way we feel is very important in our health. So those expectancy effects are really very important. We need to control for that. So the way we do it is we make a study at least single blind, and that the people receiving our treatment, in this case the drug, are not going to know what drug they are receiving. Now, in a typical study, particularly one done in our own country, the USA, people are going to know that they might be receiving a new drug or a placebo. We can't lie to people. That's not ethical, and that would go against basic guidelines as well. So the other part of being double blind is we want to make sure that the crews who are on scene for this study, they don't really know what they're administering. So they might flip a coin, but instead of being told that they should now administer the vasopressin or the epinephrine, they're just going to be told administer drug A or drug B. They know it's a drug that they need to use in this situation, but they do not know which drug they're actually administering, because it's possible that their own expectations can influence the outcome of the study. So do you see how amazing this is? This is where we really use our own brains here to help kind of protect ourselves from ourselves. We don't want our expectations to screw up the study, so we do what we can do to protect ourselves from those expectations. We hide information from ourselves. And of course, later on, we can pair up who received which drug. And then also, to reduce any experimenter effects, as we call them, the ambulance crews use the same procedures for all subjects. So all people were treated the exact same way, except one thing. This is the beauty of the experiment. There was only one thing that differed between the two groups. I hope by now you can tell what that one thing is. And it's that in one group, the people received vasopressin, and in the other group, they received epinephrine. Everything else was the same. Therefore, at the end of the study, when we find out that the new drug improved the chances of reaching the hospital alive by 40%, when we find that out, we know it's got to be due to the one thing that differed between the two groups, and that's the vasopressin. So that's why in an experiment, we can say with confidence that the thing we manipulated, the vasopressin in this case, really did cause an increase in the probability of reaching the hospital alive. All right, so by establishing strict control, experiments will lead to only one reasonable conclusion. And this is just kind of summarizing what I just said. And that reasonable conclusion is that the explanatory variable did or did not cause changes in the response variable. So in this case, the type of drug did cause changes in survival rate. Without those strict controls, results would be very confusing, like in correlational observational studies. And when we have those confusing results, we can't really determine exactly what's going on. We say that the results are confounded. That's what this term is all about right here. The results are confounded. And it just simply means they're confused. And really, ultimately, all correlational research is somewhat confounded because we're not able to determine what variable is causing what. We're able to learn about some really important, very interesting correlations, but we're not able to determine causally what one variable is causing changes in another. Okay, let's just kind of end here by talking about another type of research study that's known as a meta-analysis. And a meta-analysis you might want to think of typically a series of studies, because what we're kind of doing is packaging a bunch of individual studies together and then looking at the big picture. So that's where this quote kind of comes in. It's impossible to see the forest without looking at all the trees as they stand together as a group. So the forest exists with all the trees. Well, it's pretty similar with research. If we don't look at a bunch of similar studies, how can we really understand what's going on? How can we really see the trends that are involved? This is why my blood boils every time I hear on the news about some small-scale research study that finds something relatively interesting. Then the people reading the news make kind of a big deal about it. And many people who haven't taken classes like this, they might get all excited about it. And although I'll find these new findings very interesting, I always think to myself, that's great. Now go back and run the study again. And if you find the same results, then come back and talk to me. And then go run it again. And if you find the same results again, come back and talk to me. Because we need to see some type of replicability. Replication is very important in research. And that's somewhat what meta-analysis is all about. By looking at a bunch of studies together, we can get an overall look of the trends. We can get an overall look at the effect that's actually going on. So in a meta-analysis, researchers review many past studies. The meta-analysis considers these studies as they are combined together with the aim of finding trends that might not have been evident in the individual studies. That's another important point. Sometimes individual studies might find a really small effect. So some drug might have a positive effect, but it might be too small to be statistically significant. Well, imagine if a bunch of these little studies are finding that same really small effect. If we were to put all those individual small studies together into a meta-analysis, we might now have enough statistical power to find a statistically significant effect. So I like to give students this analogy. Just imagine if someone in our classroom, when we're all together, drops a contact lens. There is something down there on the floor, right? There is some effect, if you want to kind of look at it that way. There is a contact lens on the floor. But because it's so small, the person who dropped it might not be able to find it. It's there, but they might not be able to find it. But now imagine if we're all looking for it. If we're all looking for this small thing, then we might be able to find it. That's kind of what a meta-analysis is like. By putting together all these small studies, we might be able to detect when small effects really do exist. Because sometimes, like let's just use a drug study as an example, like we've been doing. Sometimes drugs have very small effects. And that'll be a topic for a later discussion. Just want to make sure for right now that you understand what meta-analysis is. All right, that's enough for today. That is the key content from section 1.3. When we get together next time in a video, we'll talk about the last section of chapter 1. For now, that is all. Thanks.